So in the last video, we found the z-score necessary for a 95% confidence interval. Right now, we're going to do another one for a 98% confidence interval. So, to figure out the z-score necessary for a 98% confidence interval, first step we're going to do is we're going to go ahead and draw our bell curve and label what we want. We want it to be the middle 98%. That is, in the center here, I've got 98, which means on the end tails, I would take 100 minus 98 and get 2. That's for both of them. If I only want the left end, I'll take that 2, divide it in half, and I'll get 1. So that is, if there's 98% in the middle, there's 1% on that lower end. My next step is to go ahead and find that on my z-table. I'll be looking at the negative side because I'm in the lower half, and I'll be looking at 0.0100, converting that to a decimal. Looking at my z-table then to try and find my 1%, I get as close as possible, and looking at it here, I'm getting pretty close to 1%, like right around here or so. So looking across the rows and columns, I get as close to 0.01 as possible, and I notice this is pretty close, and that's pretty close. To figure out which one is closer, I would take my 1%, or 0.01, and subtract each of them off. The first one, 0.0102, is 0.0002 off. The second one is 0.0001 off. So it turns out this one is just a tiny bit closer. That's the one I'll use then. Tracing it up and out, I'm going to get a z-score of negative 0.233. Once again, this will be the z-score for the lower end. Because I want the upper end as well, all I have to do is realize that because it's symmetric, it's got the same number, just different sign. In a confidence interval, we'll account for the lower and the upper by putting plus or minus, which means for the third step when I reach my result, I'll just go ahead and write, in order to be 98% confident, I need to go out 2.33 standard deviations, both for the positive and the negative side. We'll go ahead and look at one more example here, and that is we'll look at what it means to be 99% confident. To be 99% confident, I'll do the same thing. I'll draw my bell curve. I'll label my 99% in between. That means I have 1% left over, or 0.5% for just the left end tail by dividing that in 2. 0.5% as a decimal, keeping really close track of that, is 0.0050. Next thing I'll do is I'll go ahead and I'll look at my z-table. Looking for 0.0050 on here, I notice as I scroll down that I'm getting pretty close right in this row right here. So tracing it across, I see two values. I see this 0.0051 and this 0.0049. I need to figure out which one is closer, and in order to do that, I take my actual and subtract it from it. So 0.0051 minus 0.0050 gives me 0.0001, and the other one, 0.0049 minus 0.0050, gives me 0.0001 as well. Notice that these two are the same distance from my actual value. And what that means, according to what we've done before, is I'll go ahead and I'll find both of their z-scores, and then I'll average them to find my z-score. So tracing 0.0051 over and out, I'm going to get negative 2.67. Tracing this one out right here, I'm going to get negative 2.68. So that is, once again, when I trace 0.0051 out, I get negative 2.67, and when I trace 0.0049 out, I get negative 2.68. I'm doing both of them because they're the same distance from my actual value of 0.0050. Now I've got these two, I'm going to go ahead and average them. I'm going to do that by adding them together and dividing by 2. And when I average those, I get a z-score of negative 2.675. Once again, this gives me the z-score on the lower end. So this number over here is negative 2.675. The upper would be 2.675. Because my confidence interval will include a plus or a minus that I'll use, when I write down the actual z-score, I'll just write down the positive. The negative will come from the formulas we have. So to be 99% confident, I have to have a z-score of 2.675. Notice that I've gone from a z-score of 1.96 to 2.33 to 2.675. That is, the more confident I want to be, the further out I have to go, the larger the z-score.